All right, as you see, well, I don't know if you see it or not, but I'll tell you right now. You see this word rational. Everybody see that? We might have discussed this earlier in the year. I usually do. But you see the word ratio inside that word rational. So when you see the word rational, you see ratio. What do you think of when you think of a ratio? You're comparing one thing to another, right? Yeah, that's a ratio. You compare this to this, and this is twice as much, or if you do odds, if you're a betting person, which I'm not, but you say the odds are like 3-2 or something like that, or 5-8 or whatever. Okay, like in horse racing. I don't know. I've never bet in my life, so I don't really know much about it, but I do know it's a comparison. So 3-2, 5-8, 1-2. Those are all ratios. They're fractions, and that's what we're going to do. So we're going to start super, super basic right now before we get into what's on the worksheet. All right, so the stuff that I'm going to do at first, it's not on the worksheet. It's just to kind of lead you up to it. All right, so we're going to do some super, super basic fractions. Now, we've done this early in the year. Now the bells ring. So we've done this early in the year, but we're going to, again, we're going back to the basics. That's what we're doing with these worksheets. That's what I call it, going back to the basics. And so that's what we're going to do right now, going back to the very basics. So I'm just going to make these up off the top of my head. I didn't take any notes on this, but let's do this. So what if I had 2/3 plus 5/3? And I ask you to add those two fractions together. So what do you think? You just look at it and say, I don't know. I don't know how to do fractions. I haven't learned it.
It's 7/3.
It's 7/3. Because here's the rule. Now look, I'm going super, super basic here because the same rules apply. Because we're going to do solving rational equations. All right. So we're going to actually solve for stuff. So I think it's important to be able to know how to add fractions together in order to solve for stuff. Yes, ma'am. Yeah. It looks like, some of these answers are improper fractions, but I'm not going to make you change it from an improper fraction to a mixed number, okay? I'm not worried about that. In algebra, like back before you took algebra, when you took regular basic math, in 4th, 5th, 6th, 7th grade, whatever it was, it seemed like teachers always, and it's not a bad thing. I think it's perfectly fine. For instance, right here, let's just do this and we'll talk about the improper fraction in a second. So when you're adding fractions, the first thing that you want to do is to find a common what? What's the word? Common denominator, okay, when you're talking about fractions. Okay, when you're talking about fractions, you want your denominator to be the same. When I say common denominator, it means you want them to have the same denominators. Well, first of all, do they have the same denominators? Yeah, absolutely. They have the same denominators. So that makes this one the world's easiest fraction, almost. Because what do? When you have a common denominator? Your answer is just going to keep that common denominator, right? You don't add them together. You don't go 3 plus 3. You just see that you have a common denominator. You keep your denominator here, and then what do you do with the numerator? The numerator is the one on top. What do you do with the numbers on top now? Just add them up. That's it. Okay? As long as you got a common denominator, how do you figure out what the top's going to be? You just add them up. 2 plus 5, 7. I am perfectly fine if you keep it 7/3. Now, this is not the kind of problems that are going to be on the worksheet. Again, what I'm doing is just laying a foundation, and we're going to lead up to this. We're going to lead up to the stuff that's going to be on the worksheet, all right? Now, the question was, are we going to have to do improper fractions? Well, this is improper. Why do I call it an improper fraction? That's right. The numerator is bigger than the denominator. When the top is bigger than the bottom, then that's called an improper fraction, right? And so what we can do, we say, how many times does 3 divide into 7? It doesn't go evenly, but how many times would it go into it? It goes twice, right? So you put a 2, okay? And then, I don't know how I haven't taught fractions. I don't even know if I've even taught basic fractions before because I've always taught algebra on up. But when you're a kid and you learn fractions, you say, how many times does 2 go into 3? 2 times 3 is 6. Then you subtract. 7 minus 6 is what? 1. So it's 1/3. So that's how you change an improper fraction to a mixed number. It's a mixed number because it's a mixture of a what? Whole number plus a fraction. All right? We're not really going to worry about that, though. Okay, so don't worry about that. Okay, just this part right here. Okay, knowing that you have a common denominator. I don't have everybody paying attention to me. Realizing that you have a common denominator, you can do this. So what if you had something like this? What if I had 2 over x plus 5 over x? This is just as easy. I promise. I'm not just lying. I'm not just saying it because I'm a math teacher. It's just as easy. So what do you look for? You look for a what? Do we have a common denominator? Absolutely. So what do? We just write down whatever that common denominator is. Okay? We don't add them up. Okay? We don't add up the denominators. You just keep your common denominator the way it is, and then you just add up the top. 2 plus 5 is 7. Yes, sir. Yes. Leave your phone on your desk, okay? 7 over x. And that would be the answer. It's kind of weird looking, but that's what it would be. You with me so far?
Yeah.
Okay. So, let me think what else we can do. Yeah, what if you had this? Now we're starting to kind of get into what we're going to be doing here in a minute. Not quite yet, but in a minute we will. So what if I had, let's see. What if I had 5x plus x? And we'll just stick some numbers up here, 3 and 7. Really doesn't matter what the numerator is. I just want to do this. Now, do we have common denominators now? We do not. So this is where the problem comes in, right? If everything had a common denominator, fractions would never be a problem. Be super easy, all right? It's when you don't have a common denominator, that's when you want to find a common denominator. So what we're trying to do is this. We're trying to find a number that x divides into and 5x also divides into evenly. We'll say it that way, okay? So what number does x divide into and 5x divide into evenly? No. Let me say it a different way. Let's do it this way. We did this before earlier in the year because sometimes they may, I don't know, looking at this worksheet, yeah. I'm trying to think of the best way to explain this. Let's do this. Let's take those two numbers, 5x and x. Remember we did this, I don't know, a couple months ago when we had to find common denominators? We did this a while back. So what you're going to have to do is this. I want to see what shows up. Remember me saying that phrase? I said it over and over and over again back in the day. All right? I don't know, a month, 2 months ago, maybe something like that. So what numbers show up? A 5 and an x, right? Would you agree? What number shows up here? Just an x. Just an x, okay? So what we're going to do, tell you what, let's forget all that. Let's just do this. So what we're going to do is what number shows up? There's a 5. So I write down 5. What else shows up? There's 1x here and 1x here. Now they show up the same number of times, right? Okay, so we just pick one of them. If it shows up just once here and just once here, we just pick one of the x's. And that right there is your least common multiple, or in this case, a common denominator. It's just 5x, right? So use that little trick, okay, in order to find what your common denominator is. So what if you had 3 and 12? Let's use that trick to figure out the common denominator between 3 and 12, all right? Well, what we're going to do, when it's a regular number like this, what we're always going to do is break it down into its prime numbers. So 3 is already prime. I'm just going to write a 3. What about 12? What times what is 12? 4 times 3. But are all these prime? No, because I can break down 4. Let's break down 4. What's that going to be? 2 times 2. So 2 times 2 times 3. And I also have a 3 over here. Everybody with me? So I just broke it down. When they're regular numbers, you break them down until you can't break them down any further. You know what I mean by break them down, right? What times what? Right? It's prime if it's only 1 times 3. So 4 is not prime because it's also 2 times 2. So you break it down as much as you can. Now we do the trick. We say, what numbers show up? Well, what number shows up here? A 3. What numbers show up here? A couple 2s and a 3. So if there's 1 3 here and 1 3 here, how many do we pull out of there? Just one of them. Okay, one of the 3s we pull out. Hope everybody's watching. So you pull out 1 3 here and 1 3 here. What other numbers show up? They don't have to be in both places. Okay, because like right here, there was no 5 over here, right? But we still pulled out a 5. But there's 2 2s. So there's no 2s here, but there's 2 of them here. So if they show up more than once, we pick the ones that show up the most number of times. So it shows up twice, so I pick what? 2 times 2. Everybody see that? I pick one of the 3s, and I pick both of the 2s. And then you multiply them together. What is that? That's 12. So what's my common denominator with 3 and 12? It's 12. Okay? So let's go back to this. So what was my common denominator with 5x and x? It's 5x. Now here's the thing. Did I do anything to this to get 5x? No. Well, technically I multiplied by 1. All right, but really I didn't do anything. So I don't do anything to the top. I don't mess with the top. But what did I do to the x to get to 5x? I multiplied it by what? No, I didn't multiply by 1. Just a 5. Just a 5, not a 5x. Okay? I multiplied. What's that? Why not? Hold up. Hold on just a second. All right, so we multiply this by a 5 to get to this. So if I multiply this by a 5 to get 5x, what am I going to have to do to the top? I'm going to multiply that by a 5 as well. So what do we get here? That's going to be 35. So I had a 3 to begin with right there, right? And then what's this going to be? Plus 35. So I got a common denominator, and now I add the numerators. That's going to be 38 over 5x. It's kind of an ugly answer, but that's what the answer would be. Okay? It's not exactly what we're doing on this worksheet. Okay? And I'll tell you what I'm going to do. This worksheet is kind of split up into 2 different sections. The second page or the back page is a little bit different than the front page. So I'm just going to give you the front page to do tonight, and then tomorrow I'll give you the back page to do. Okay? So we'll split it up into 2 different days. Let me do this. Let's just start. I think I gave you enough background. Let's start with number 1. Here's what it is. Everybody write this down, because you're going to have to be doing it anyway. Right? This is going to be... Yes, sir. Yes. All right, there we go. Now, what we're going to do, we're actually going to solve for m. So this is a little bit different than what I was just teaching you, but you will have to know how to add fractions, though. All right, so you're going to solve. In this case, it's m. That's what you're going to solve for. So you want to get m by itself. So your answer is going to be m equals whatever. But what do you think we can do first? Look at this right side. Common denominator. That's right. Let's add the 2 fractions together, right? They're fractions. You got common denominators. Let's add them together, right? So it's basically what I just finished teaching you. And it's the easier version of it because we don't even have to find a common denominator. Okay? Make sense? So watch. This is the left side. Got an equals here. Now, let's add these 2 together. It's super easy because, why is it super easy?
The same denominator.
Because it's the same denominator. That's right. You have a common denominator already, so it's actually pretty easy. So you just write down the common denominator, and then what do we do with the numerators? Just add them up. That's right. What do you mean how? It's m minus 4 plus 2. You know how to do that. Is there anything to add the m to? No. This is a negative 4 plus 2. What's negative 4 plus 2? It's negative 2. It's negative 4 plus 2. So it's a negative 2 or a minus 2. That's how you add them together. Make sense? Yeah, that was pretty basic, right? I mean, the only thing halfway difficult about that part was just adding those things together. And that was easy. Negative 4 plus 2. Now, let's go to this step. Remember, I want to get m by itself, don't I? So what about this particular problem right now don't you like about it?
They're not the same denominator.
Yeah, but you got an equals in between, so you're not even trying to add them together. So that's not even an issue. You don't like the fraction, right? Yeah, the denominator. You don't like that. So what is this m? What's happening to this m minus 2? It's being divided by 3m squared, correct? All right. So so what are we going to do if something's being divided? How do I get rid of something that's being divided? I multiply. So watch. So I'm going to multiply by 3m squared. Do you see that? I want to get rid of this. And then I come over here and I multiply by what? 3m squared. So watch what happens. It works out really nice. So the 3m squareds, what happened? They cancel out. That 3m squared cancels with that 3m squared. That's why we did it. So they go away. Equals, what's going to be on the right side now? What's left over? m minus 2. What's going to happen over here? What cancels? Just the m squareds. Look, this m squared cancels with this m squared. Now what do we do here? Come on, what happens? There's a dot. You multiply. That's right. It's 3 times 3. What's 3 times 3? It's 9. Now, it's really easy, and now I can get my answer. So how do I get m by itself now? Just add a 2. That's right. Add a 2. And what's m equal to? 11. That's it. Okay? You don't have to check on this. Let me see something here. I'm trying to figure out how to pause this because I got to go do something really quick. It's not that. Oops. I thought, oh, right here. Let's see. Yeah, this pauses. All right, I think we're back to recording again. I think that's the first time I've ever paused it on here, so I wasn't sure what to do. All right, let's do another one. It was paused. So let's do another. Here we go. We'll do number 5. And that should cover it for the first page of this worksheet, okay? So let's see what we got. You writing this down?
Yeah.
3n plus 15 over 4n squared. This is a little bit different. It's a little different. Not much, but a little. N squared. Actually, you know what? This really isn't any different. Yeah, let's not do number 5. Forget that. Sorry. Let's do number 6.
Oh my God.
I want to do one. I want to do one that's going to look a little different. But that one wasn't what I was looking for. This is the one. Okay. So we did something earlier that led us up to this. All right. And the reason I did that is because of this problem right here, or one like it. On the other problem, we started off having a common denominator right away, right? So all we did, listen, all we did was keep the denominator the same and then just add the numerator. But look at this one now. Well, there's a lot that's the same, but not the denominators, not exactly the same. We got a couple things that are similar, right? Okay, but they're not exactly the same. So what are we going to have to do? What's our common denominator? Guys?
2n.
Is it just 2n? It's 2n squared. So for instance, let's use the little trick. So I've got 2n squared right there. I got 2n here. What numbers show up?
2n.
Well, I got a 2 and a 2, right? Remember we split those like this? We got one side and the other side. So I got a 2 and a 2. Now they both show up once, so how many do we pick? Do we pick them both? No, we just pick one of them. Okay, so just pick one of them. But now we have an n and an n squared. An n squared is just n times n. So which one are we going to pick? The n or the n squared? If it shows up in both places, we take the one that shows up the most number of times. All right, so the n squared shows up the most number of times. Agreed? That's our common denominator. That works every single time. Now, most of you guys should be able to look at this and just say the common denominator is 2n squared. If not, always go back to this. Okay? So, what are we going to have to do? We got to get this to be a 2n squared. So what am I going to have to do to this in order to make it a 2n squared? Multiply it by an n. That's right. You see that? Now it's going to be 2n squared. But I can't just do that. I can't just arbitrarily just multiply the bottom by an n. But I can do what? Multiply the top by the n as well. We're allowed to do that. Why are we allowed to do that? Come on. Now, it's not whatever you do the bottom, you do the top. That's whatever you do the left side, you do the right side. What happens here? Look at the n over the n. What is that? Say it. It's a 1. You're multiplying by 1. You're allowed to multiply anything by 1. Does it change the value of it? No, it doesn't change it. So that's why I'm allowed to do it. It's not because whatever I do to the bottom, I do to the top. Okay? It's because it becomes a 1, and I can multiply anything by 1. All right, let's keep going. So what do we have? Let's write it all out. I'll write down every little possible step for you. We got 5n over, what's this going to be now? 2 times n times n. That's 2n squared. That's right. And that's what we wanted it to be, right? Because we wanted a common denominator. Now, what we have now is where we started that first problem, right? Because now I have a common denominator, don't I? So let's write it with a common denominator, 2n squared. Now, what do I do to the top? Add them up. Now, can you go 1 plus 5 is 6? No, because this is not just a 5. It's a what? It's a 5n. So I have to write what? 1 plus 5n. Okay? It's not squared. It's just a 5n. 5n plus 1. And then over here, we just write n minus 2 over n squared again. There's nothing you can do with that. What was the second step we did on that first problem? You had to get rid of something. What'd you get rid of? The n squared. Let's get rid of the n squared. Okay? So let's get rid of the n squared. Actually, if you wanted to, you could get rid of the whole entire 2n squared if you wanted. Let's do that. Okay? I think it makes it one less step. Yeah. So watch. Let's get rid of the 2n squared instead of just the n squared. So I'm going to multiply this by 2n squared. And then I'm going to come over on the right side and multiply that by what? 2n squared. What allows me to do that? Give me the rule. Yeah, this is the one where whatever you do to one side, you do the other side. Okay? So what happens here? That cancels. All right, so bring this down. It's just 1 plus 5n. What happens here? Does this 2 cancel? No, because I don't have a 2 on the bottom. But the n squared does. This n squared cancels out with that n squared. So I'm left with 2. What is that 2 doing to this n minus 2? It's multiplying. So what I'm going to do, now this is a little bit different than the first problem, just a little bit. It's multiplying by this, so I got to put that in parentheses. Now, what am I going to do with that 2? How do I multiply 2 times a parentheses n minus 2? Distribute, that's right. So I take the 2 and I distribute it. So I get what? What? What's crossed out? The 2? I didn't cross out the 2. I said specifically, go back and watch the video. I said specifically, the 2 does not cross out because you don't have a 2 on the bottom. Okay? So just the n squareds cancel out. Because I know that's what some people would do. Some people would cancel out the 2. That's why I specifically said the 2 does not cancel out. Only the n squareds cancel out here. It canceled out here because you had a 2 on the bottom, right? 2 on the top, 2 on the bottom. But you don't have a 2 on the bottom of this, so the 2 doesn't cancel out. Now what we can do is some basic pre-algebra, and we can solve for n. I would do that by subtracting a 2n. All right, so I'm going to put the n's on the left-hand side. Let's get rid of that 1. I'll subtract a 1 from both sides. That cancels. That leaves us a 3n. This cancels, and this leaves us a negative 5. And then we're going to divide by 3. Divide this side by 3, so n equals negative 5/3. And that's your answer right there.
We have to simplify it.
It's simplified.
No, like
If it can be. So pretend, now this problem didn't do this, but pretend it came out to be negative 12/3. Okay, let's say you did all the math. It came out to be negative 12/3. You cannot leave it like this. You must simplify this. And what is that? That's just negative 4. Everybody see that? Or if it came out to be negative 6/9, what does that simplify to be? Right. Well, not 1/3. Right, it's 2/3 because watch, 3 goes into this twice, 3 goes into this 3 times, it's negative 2/3. But does this simplify? No, 3 doesn't divide into 5, so we're good. Just leave it like that. There's no reason to change that to a mixed number. All right, no reason at all. At least in high school algebra, there's no reason to do that. We good? Yeah, I would say all the other problems are pretty much like the 2 that we just did. Okay, so with this worksheet, it's worksheet 12, but I'm only doing you're only doing 1 to 10 today, and I've done 2 of them for you, so you're really only doing 8 problems. All right. So tomorrow we'll do the back sheet of it. So I'm going to give you both front and back, but just do the front. Just do 1 through 10, and then tomorrow I'll teach a little bit more, and you can do whatever it is, 11 to 20 tomorrow. Okay? All right.